Okay, folks, this is number 41, and the question states you are to this tick equation here, put it equal to 0.5, and can you find the solutions that match between 0 and 2 pi? So that's just a short way of saying between 0 and 2 pi. So what I'm going to do here is going to find the general solution, and then we're going to use the general solutions to generate problems that fit between here, and we'll also very quickly put it onto Desmos, and we'll see the answers there. But the key skill set here I want to try and get across to you is, can you form the general solution? Because that's a requirement, a merit level requirement for the assessment. Okay, so the first thing we're going to do, this is not really a new lake, but I suggest you do this. Let alpha equal the angle bit, which in this case is 2x. And it simplifies the expression down to sine of alpha equals 0.5. And you get your calculator out here. Okay, but now if you've done a bit of special triangles, you'll probably realize that if you see an angle, a sine or a cos angle equal to half, you actually can this triangle here. If you haven't covered special triangles, don't stress. It's a bit of a hidden art, but basically this angle here is pi over 3. This one here is pi over 6, and if you take that angle there, opposite over hypotenuse is sine. So here, sine pi over 6 is opposite over is a half. So straight away, what does that suggest? Alpha is pi over 6. And what's cool about this, that is not a decimal. That is an answer, which is an exact solution because it's a fraction of pi. Now, obviously, I could have done that on my calculator here. This calculator is a bit special. It's a more modern one, but shift setup, just confirm I'm in radians mode. Yep, okay. So if I did inverse, beg your pardon, how am I going to do this? Yeah, inverse sine of 0.5, and okay, my calculator gives it as the absolute, or the fraction of pi, but other calculators would have given this horrible answer, 0.523598775. Yuck. Okay, which is better? Come on, which is better? This decimal or this thing here? This wins hands down, okay? So in reality, I don't need the calculator. I can just put it over here. Okay, so now, what do we do now? This is the tricky bit. I'm just going to go back to here, and in fact, no, let's open up a... okay, and this here is what we're looking for. So there's the ruling. Okay, if sine theta equals sine alpha, then theta equals this bit here. So let's just copy that bit there. Theta equals n pi plus minus 1 n alpha. Okay, so that's what I've just written there. So let's make sense of this. So this bit here is your theta. That's your angle. So that bit goes here. That's 2x equals n pi plus minus 1n. What's alpha? Alpha is this thing here, pi over 6. Okay, and now you solve it. Divide everything by 2. X equals n pi over 2. And divide that by 2. That would give you brackets n pi over 12. Okay, and now that's your general solution. So in theory, this thing here can generate all the answers between there and there. So basically, let's say n equals 0. If n equals 0, what does that give you? X equals, what's that? 0 plus. Now, something to the power of 0, that's 1, so the answer is pi over 12. That is one solution right there. It is pi over 12. And does it fit between 0 and 2 pi? Yep. Okay, let's try n equals 1. X equals, put 1 in here, so that gives you pi over 2 plus. Now, this is the power of 1. Negative 1 to the power of 1 is negative 1, so it's going to be minus pi over 12. Do some quick algebra here, fractions. Okay, that's going to be 6 over 12. That's going to be 5 pi over 12. And yes, that works. N equals 2. Okay, 2 over 2 is 1, so that's going to be pi. And minus 1 squared is positive 1, so that's going to be plus pi over 12. That's going to be 13 pi over 12. Yes, that works. And the final one, let's put n equals 3 in. That's going to give you 3 pi over 2. Now, minus 1 cubed is negative 1. So negative 1, that's going to be minus pi over 18 over 12, which is like saying 3 over 2 minus 1 over 12 gives you 17 pi over 12. Hey, just for argument's sake, let's try n equals 4. What happens here? That becomes 4 over 2 is 2, so that gives you 2 pi. Now, minus 1 to the power of 4, an even number, that's going to be a positive, so that's plus pi over 12. And basically, it's going to be what? It's going to be, let's take a common factor here, 2 and 1/12 pi. So that obviously is more, so that's not a solution between that range. Hey, what's stopping you doing this? N equals minus 1. Nothing. You don't have to start at 0. If you plug that in, you'll get an answer which is not inside that range as well. Okay, so what we're going to just do here is very quickly go to DES, and you'll see how quick this is. So we've got sine 2x, y equals 0.5. Okay, so there are all the solutions. There's one there, there's one there, there's one there, and there's one there. So obviously we're going between, actually let's just put there, let's just show between 0, x, 2 pi. That hasn't worked. Okay. Okay, it's not liking what I'm doing. Okay. Excuse me, just having a wee bit of, okay, I'm just going to put down here. Okay, 0. Okay, nope, this is not happening. As you can see, even I'm starting to have some issues here. Okay, that looks a lot better. Okay, slows you down. Okay, right. So what we're seeing there, there's what are the solutions? There's that one, there's that one, there's that one, and that one. So you can sort of see pi 12th, 5 over 12, 13, and 17 over 12. And if we look back here, there are our solutions as we've found them. And this one here would have been, what's this, 25 over 12? That would have been, if I kept up there, it would have been over there somewhere at 25 over 12. Okay, that's all.